Hello students and welcome to Unit 5 Part 2 Lesson 3. In this video we are going to learn to graph relationships using input-output tables. Our essential question is, given an equation, how can I graph the relationship on a coordinate plane using an input-output table? Now let's think back to Unit 2 Lesson 1 and review what we learned in that lesson. In that lesson, we learned about the parts of the coordinate plane. We know that it is created by an x-axis and a y-axis. The center where the two axes meet is called the origin. And when the two axes meet, it creates four quadrants: quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Locations within this coordinate plane are described as ordered pairs. The first value in an ordered pair is the x value, which tells the location on the x-axis. The second one is the y value, which tells the location on the y-axis. If the x is positive, it goes to the right of the origin on the x-axis, but if it's negative, it goes to the left of the origin on the x-axis. If the y value is positive, it goes upward on the y-axis, but if it is a negative y value, it goes downward on the y-axis. Now, I also want you to think back to Unit 5, Part 1, Lesson 3. In that lesson, we learned that tables are a way of organizing inputs and outputs into columns and rows. And we learned that an ordered set of ordered pairs and a table can both represent the same relationship. In other words, they're equivalent representations. You also learned to transfer from one to another representation. And we know that if we have a table, that all the inputs are the x values and all the outputs are the y values. So this row of the table literally means -3, 6. So if we start listing them, we'd say that is the ordered pair -3, 6. This is the ordered pair -2, 4. This is the ordered pair -1, 2. This is the ordered pair 0, 0. This is the ordered pair 1, -2. This is the ordered pair 2, -4. And the last row represents the ordered pair 3, -6. And this is the set of ordered pairs represented by this table. Today, we are going to learn and link these two lessons together by saying that there is another way to show that same equivalent relationship, and that is on a graph. Remember from the introduction of this unit that a graph is a way of depicting many contexts on a coordinate plane. Now, there are many ways to graph an equation, but today we're going to learn the most basic way: to use an input-output chart to graph the relationship. So here's how you create a graph from an input-output chart. The first step is, if necessary, create the input-output chart if it's not already given to you. Second, write or imagine the ordered pairs depicted by the input-output table. Third, graph each ordered pair individually on the coordinate plane. And then fourth requires a decision. If the relationship is discrete, do not connect the points that you've made. If the relationship is continuous, you connect the points. If the input-output chart or original equation is not depicting a real-world situation and you do not know whether it will be discrete or continuous, then treat it as if it is continuous. So, for example, let's look at that same table that we looked at earlier when we were talking about Unit 5, the Unit 5 Lesson 3 video. If we create those ordered pairs just like we did earlier, we can then graph them on the coordinate plane. So graph -3, 6, -2, 4, -1, 2, 0, 0, 1, -2, 2, -4, and 3, -6. Now, since this is not representing a real-world situation and we do not know whether it should be discrete or continuous, we connect the points on the graph, and we also put arrows on each end to mean if the pattern continued, it would go in these directions forever. Let's look at a real-world example. We looked at this real-world example earlier when we were talking about how to create the table. So it says the number of campers in a summer camp will allow to register is 4 times the number of counselors available. In other words, the equation y equals 4x represents this situation. So if we multiply x by 4, we can generate the y value. Together, the inputs and outputs create the ordered pairs that we can then graph. Now, we cannot fit 24 along the y-axis, so we're going to have to count by something different. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 lines. So let's count by twos. We do not need to label them all, just enough to show the pattern. So 2, 4, 6, and here we'll count by ones. 1, 2, 3,